Welcome. So in this video, we're going to do several things, and a lot of it has to do with just protecting our network. Going to do some spanning tree protection stuff, also some LAN mitigation stuff, and also just some basic best practices for trunk links. But first, let me talk a little bit about our adjusted topology here. I've taken distribution 2 switch here and simplified things. Notice I only have the one VLAN 40, the 1040.00/16 network, and all the devices have an address on that network. Our PCs have received their addresses from the DHCP server. I do have trunk links, just because we're going to do some best practices for trunk links here, but I'm not really using them, but it's not a bad idea to configure trunk links for our inner switch links, just in case we do add other VLANs. So first, let me go to PCA here and show you that. Here's my configuration. Okay, it has an IP address, there's its default gateway, and able to ping 1040.00.99. Let me do that one more time here, just make sure. Yep, looking good. Okay, it's pinging the server here. Let's look at distribution 2, and I'm doing a show running config. What I want you to see is I don't have anything but really the basics for the trunk links. Just switch port mode trunk. So I've statically configured it as trunk links, but I'm not incorporating any best practices as far as I'm not adding any native VLAN or doing any kind of trunk, allowing only certain VLANs on the trunk. So let's go ahead and do that. So I'm going to do config T here, and I'm going to, I'm going to add, this is our native VLAN 254, that'll be our native VLAN. And then I'm going to configure both these trunk links with some best practices, let's call it, for the trunk link. Yeah. All right, so I'm going to scroll up here. In a moment here, I'm going to talk about these commands, but let me pause the video first, because I'm going to get a lot of these errors down here. These native VLAN mismatch errors. So we're not dealing with those. I'm going to go ahead and configure the rest of these switches with similar configuration. All right, so let me return back to our distribution 2 switch. So again, I've configured the native VLAN. And again, this is all what we've done in previous videos, previous labs. For these 2 ports here, I first shut down the interface. It's sometimes best to, when making major configuration changes to a port, like actually a trunk link, changing the allowed VLAN, the native VLAN, it's usually best to shut down the port first. Again, I just statically configured it to switch port mode trunk, which it was already configured as. So I'm only allowing these VLANs. VLAN 1, which is allowed by default, is I can't get rid of VLAN 1, that's control traffic. VLAN 40, which is the only VLAN we're using here, and our native VLAN, which is the same on both sides now, because I've configured all these switches to be the same as well. And I also turned off dynamic trunking protocol, so switch port non-negotiate. Okay. And so you can see I shouldn't be getting any more of those messages. And just to show you, I've done the same on these other switches as well. Okay. All right. So that's usually kind of best practice for trunking. Now let's talk a little bit about spanning tree protections. First thing I want to do are best practices for spanning tree. First thing I want to do is make this the root bridge. We talked about this in previous video. So I'm going to make it the root bridge for both VLAN 1 and VLAN 40. Let me go ahead and paste that in. All right. And if I take a look at it, I'm going to just go do show spanning tree VLAN 40. Actually, let's give it a moment, make sure spanning tree converges properly. And let's take a quick, it should give it enough time there. All right. So I can see here that now this is, let's take a look at VLAN 40 specifically. This bridge is the root. Okay, there's its root. The root ID is of this bridge, by the way, is here's its priority, which is it actually, this command here lowers the priority from 32,768 to a lower number and adds on the extended system ID of 40, the VLAN number. But it is the root bridge. You can see both of these ports are designated ports. And just to kind of verify that, let's go down here to access 1-3. And I'm going to do the same thing here. I'm going to do a do command. This do is very useful because I can use the show command at the global configuration command prompt. Very useful. I can spell spanning tree. VLAN. I can VLAN 40. There we go. All right. And we can actually see that it is saying, hey, who is the root? The root bridge is, well, it has this priority and this address, which is not this switch. Going back to distribution, this switch says, hey, I am the root. All right, so it recognizes distribution 2 as the root bridge. Okay, a couple of other things we want to do here is let's talk about port fast and BPDU guard. Okay, so what I'm going to do here is I'm going to go over here to access 1.3, and we're going to configure a port FA. I'm going to do FA011. So let me do that. Interface FA011. So I'm going to create a new port here. Switch port mode access and switch port access VLAN 40. Okay. And we're going to add a device to that port. So let's go ahead and do that. Try and do this as quickly as possible here. All right, so what I'm going to do here is add a device. While I'm doing this here, I'm going to bring this up. PC0. And I want to make sure it's actually configured for DHCP. So I've gone ahead and done that. And yeah, DHCP. All right, and I'm going to go to the desktop. Command prompt. All right. So what I'm going to do is connect this device to our network. And what I want you to notice is, as soon as I do that, FA011, notice that this light is green. So if I do IP config here, notice it does not have an address yet. Matter of fact, it's trying, but it says, hey, I've been trying with DHCP, but I can't get an address. Why? Because this port here on the switch is going through its listening, learning states and hasn't started forwarding yet. Okay. So what do we normally do here? Well, what we need to do is actually configure something called port fast on this port. So it automatically goes to green, and devices, once they connect to the port, end devices can send out they'll be sending out their DHCP discover messages, and those messages will be automatically forwarded by the switch. That's what was happening before, is it was actually getting blocked. Those messages were getting blocked. So the PC 0 here gave itself this address, says that, hey, I'm not getting any kind of response from a DHCP server. Well, that's because the switch isn't forwarding them. So I just gave myself this address. So let's do this. So what I'm going to do is again, I'm still on interface fast Ethernet 011, right? Okay. So, and I would do this to all my ports where I have end devices, printers, routers, anything that's going to connect directly and is not another switch. What am I going to do? I'm going to do spanning tree, port fast. Now I get a little warning message that warns me that don't be connecting another switch to this port. And I'm going to do something else here to make sure to actually protect my network from if a user does plug in a switch to this port. Let's take a look. BPDU guard. Enable. All right. All right, so let's do this once again here. So let me pause for a moment. Okay, so what I've done is I've added another PC here, got rid of the other one, and going to connect it. Now watch the link light here. As soon as I connect it to FA011, notice it goes green immediately. Let's do our IP config. Might take a second here. We got our address. Okay. Now, what if somebody goes, I've only got this one data port. Okay, and I wish I had another data port. So what I'm going to do is this. I'm going to remove this link here. Now I've only got the one data port in my office. So I'm going to add, I brought in this little switch. I've been taking this networking class and I've learned about switches. So I'm going to put a switch here. All right. And what I'm going to do is I'm going to connect myself to my switch. All right. And then I'm going to connect, we'll let spanning tree even come up there for a second. And what I'm going to do is connect this switch now to this port. Now, before I do that, let me go ahead here and let's notice what will happen on this switch. Remember, what we've configured is spanning tree BPDU guard enable. All right. Let's go ahead, and it really doesn't even matter that this is still light as amber, because watch what happens. As soon as I'm going to actually use the right kind of cable here. Let's use a crossover cable. Why not? Use the right cable, FA011. Watch what happens. Look what I'm getting. Look what I'm these messages here. And look, the red link lights. What just happened? Okay, notice that BPDU guard. Okay, it says, hey, spanning tree BPDU guard. I just received a BPDU on a port, bridge protocol data units. The switch sends spanning tree BPDUs. And it says, hey, I shouldn't be receiving that, because there shouldn't be, this switch is saying I shouldn't be getting those, because I'm not expecting any switches to be there. So I'm actually guarding against it. And what I've done is I'm actually shutting down this port. Okay. So we can see it's actually, the port's been what's called error disabled. So what do we have to do? So first of all, the user here, maybe it's me in my office. I'm like, oh gosh, what did I do? I did something wrong. I know what I'll do. I'll get rid of this switch, hide it under the desk. So let's go ahead and do that. Get rid of the switch. Okay, all right. Let me connect my cable back in. Not sure what I did. Put it back on fast Ethernet 011. Uh-oh, I don't have access still. This port is still down, even though I removed the switch. I better call IT. Okay, so IT comes over and says, oh yes, no, Rick, it's just something that we've done to keep users from adding additional switches to the network. We don't want any kind of issues with spanning tree, too many switches, more than 7 switch diameter. Talk about this in my spanning tree classes. Anyway, that can create havoc on a network. Okay, so what the IT person has to do is, let's just make sure we're in the right port here. I know we are. Interface fast Ethernet 11 actually has to do what we call power cycle the port. Okay, so not just do a no shutdown, but first do a shutdown and then do a no shutdown. There, now we're back up. Yep. All right. So that's really very, very handy. Some other things we want to do as far as protecting our network in spanning tree is this. We've created this as our root bridge distribution 2. We want to include something called root guard. Root guard is important because it prevents unauthorized switches, or switches that we don't want to become root, from trying to become the root bridge. So what we do is we actually configure root bridge on a root guard, excuse me, on our downstream switches. So what I'm going to do is here, for example, on access 1-3, okay, so been spending a lot of time on this switch here. All right, so it knows that this is the root. Now these switches down here, for example, 2-3, it says, you're never going to become root. I'm going to guard against that happening. So what I'm going to do here is go into this interface, Fast Ethernet 01, right here. Interface FA01, and I'm going to configure root guard. So what this is going to ensure is that this switch does not try to become a root bridge. Banner tree guard root. Okay. Okay. So what happens if a downstream switch, I'm not going to go through all this, at least showing it, but you can try this yourself if you wish. What happens if a downstream switch tries to become a root bridge, meaning it has a, say, a lower priority than our current root bridge? Well, this will actually, on this switch here, we did that on this switch here, create a lower priority. This switch here that we've configured root guard on, it would trigger the root guard function. It would block the port to prevent the switch from becoming the root bridge, thus maintaining the stability and intended design of our STP topology. Basically, what it's doing is it sees this as, it's called a superior CPU. It says, I'm blocking this superior BPDU. Yeah, you're better than this one, but you're not supposed to be the root. It's, again, going to put in what's called root inconsistent state. Again, what we'd have to do is change the configuration of this switch so it's no longer trying to become a root bridge or swap it out with another switch. But hopefully just change the configuration because we know what we're doing. So it's no longer trying to become the root bridge, and most likely have to power cycle this port. Okay, normally you don't have to. Once it sees that it's no longer, once this switch sees that it's no longer getting BPDUs from this switch, trying to declare itself as the root bridge, and actually does have a better, superior BPDU. This switch, once it sees that it's no longer trying to do that, it will allow the switch. Yeah, you can be part of our STP topology. All right. So, by the way, best practice, all these things that we're doing, and I have this in the lab here, the port fast BPDU guard would be enabled on all these ports. The root guard would be enabled here and here. This would be best practices we do on our other switches as well. All right. Now I'm going to change a little bit, and what we are going to do is take a look at remote access. So if I go back to distribution 2 here, and I'm going to do an end, and I'm going to do show running config, and I'm going to filter that section. I just want to see the section line VTY 0-4. And what it's going to show me is that this switch is configured to allow telnet with this password. So if I'm on PCA, first of all, make sure I can ping my default gateway, ping 1040.0.1. Yes. All right. Let's make sure that we can telnet into our default gateway. Covering a lot of stuff here, aren't I? Okay. It says, what's the password? Cisco. We're in. Okay. All right, I can do an exit here. All right, but here's kind of the problem. Telnet is not a good option for remote management because it transmits the data, including the credentials, the password, in clear text or plain text. So it makes it vulnerable to any kind of interception or eavesdropping. So what we want to do is use a better option, which is SSH, which provides a secure encrypted communications, protecting data integrity, confidentiality, and other issues that we might just protect ourselves against potential cyber threats. So let's go ahead and on distribution 2, and we want to do this on all of our devices, okay? But I'm going to be configuring, going to configure SSH. All right, so bear with me here. I'll explain these here in a moment, okay? This here is actually what I'm creating as a domain name, okay? So this domain name, it's ssh-key.com. The domain name is used as part of the fully qualified domain name in generating the RSA keys for SSH. All right, next thing I'm going to do, and you'll see that in a moment, username, admin, secret. So I'm creating a little local database. And I could have multiple users here with different passwords, but I'm just creating one user here, admin, with the password, secret password, SSH, admin. Do that, there we go. Next, I'm going to go into line VTY, and I know this switch actually has up to 16 virtual ports lines, so that's how many people simultaneously could SSH into it. So I'll do 0 to 15. And I'm going to say transport, input, and my options, by the way, are all, which means both SSH and telnet in this case, none, meaning neither one, telnet, which we used before, but I'm going to say just SSH. I'm also going to say login local. What that means is use this local username and database for credentials. Okay. Next, I am going to, next thing I'm going to do is generate my RSA key pair used for SSH. I'm going to use a modulus of 1024. The RSA keys are necessary for encrypting this SSH sessions. And the domain name that we set earlier is used in generating these keys. All right, so let me go ahead and type this out, try to not make too many mistakes here. Generate, it's kind of a long command here. RSA general keys, modulus, I'm going to use a key size. Did I spell that right? 1024. Let's see if I spelled everything right. Yes, looks good. Okay, so the key modulus size is 1024. We're looking pretty good so far. All right, so let's go back to PCA. Remember PCA? This is where we did telnet before. Hey, let's try telnet again. Telnet 1040.01. Trying, nope, connection closed by foreign host, meaning not letting you in. Okay, so let's try SSH. SSH-L admin, and then our IP address. Password SSH admin, and now we're in. Okay, so it's that simple. And by the way, enable class. I want to mention something about what I just did here. This is true for telnet and SSH. If you do not have a privileged exec password, in our case class, you won't be able to telnet or SSH into a device. Okay, it requires that you have a privileged exec password to do that. All right, exit out of that, and I think we're good on that. We're getting there. A lot of good stuff here. All right, the next thing we do is port security. So let me pause this video a moment and just get ready for that. Okay, so I got rid of our PC right here. And now we're going to, next thing we're going to do is port security. Port security is a feature on network switches that restrict the input to a switch port to specific MAC addresses. This is going to help with enhancing network security. When port security is enabled, the switch can limit the number of MAC addresses allowed on a port and optionally specify which MAC addresses are actually permitted on that port. So it prevents unauthorized devices from accessing our network through that port, also mitigates things like MAC flood attack, where we can actually restrict the number of devices that can be on a port, so we don't have a device that tries to flood our switch with bogus MAC addresses. What does that do? It would fill up the MAC address table of that switch and maybe other switches as well, and actually just create a lot of unknown unicasts throughout our network. Anyway, this is going to help prevent that as well. So the first thing I'm going to do here is I'm on access 1-3, and I'm going to go to interface FA010, okay, where we have PCA. And I'm going to switch port security, okay? And I'm going to do an end here, and we'll do show. I'm going to do a show port security. Whoops. Maybe I just want to show you the complete command here. I'm going to look at it just for interface FA0010. All right. So a few things to kind of make note of. Port security is enabled. Okay. This violation mode, if there is a violation, it will shut down the port. Right now, it doesn't know any MAC addresses because it had hasn't seen anything on the port since we've configured this. And the maximum number of MAC addresses allowed on the port is just 1. So let's send something. PCA here. I'm going to, let's ping, let's go up there. Going to ping our default gateway. All right. So let's go back to access 1-3 switch. Take a look at this. Let's do this same port security command again and take a look at what it gives us. Okay. Notice what's changed here is it has now learned a MAC address. Okay. Now there's only a maximum of 1 MAC address allowed on this port. All right. So what happens is, remember Rick? You know, he's like, well, he wanted it to add another device to his office. Okay, and he says, so let me go ahead and let me try this here. So I'm going to add another computer. I'm going to try this again. Okay, this time, it didn't allow me last time because of BPDU guard. The IT person told me I couldn't have a switch because it detected the spanning tree BPDUs. So what if I try something else here? I know, I'm going to try a hub. Okay. So what I'm going to do here is let me kind of get rid of that right there. Okay. There we go. All right. I'm going to connect both of these devices to the hub. Bear with me here. And let's do this one to the hub. Okay. All right. Then I'm going to connect this hub to the switch. Now fast Ethernet 010 here. All right. So spanning tree is running. It's going to notice that it's not getting any BPDUs here in a moment. So let's let that age out here. Okay. So notice our line, it says down here, line protocol changed to up. So that's looking good so far. Okay. No real problems yet. I'm going to go to PCA here in a moment. And as soon as that turns amber, from amber to green, we're going to try pinging 1040.01. There we go. It's green. Let's see if we can still ping. Yep, it's pinging. Okay. I had to do an ARP, the ARP table timed out. So I do an ARP request and ARP reply. So everything's still looking good, right? Well, Rick, I thought you said that, we only allowed 1 device on there. Yes. So let's now try, let's see what happens if we try pinging from PC2. So what I'm going to do here is I'll actually add a static IP address. 10.40.0. We'll just do 77 there. How's that? Okay, and that's subnet mask. Okay, so it's on this network. Oh, look, as soon as I did that, see this red here? Didn't even wait. You know why? See, before I even was able to do this, it was trying to send out a DHCP discover message. And when this device here saw a source MAC address, other than this is just from the DHCP discover message. Before I even had a chance to try pinging because of the DHCP discover message. Let's take a look at what happened. Let me move this out of the way here. Let's go here. Look. It says change to down. What happened? Let's take a look. Let's do our show port security. Look at the port status. It's in secure shutdown. Why? Because it did not see, it saw let's take a look at our MAC address. This was the MAC address of PCA. This is the MAC address on VLAN 40. Now it says, hey, I just saw this MAC address. There's only one allowed on the port. Sorry, this is a second MAC address. So I've just shut down this port. Okay. All right. So, and that was just from the DHCP discover message. It saw this source MAC address. All right, let's fix this once again. Let's get rid of this hub. Let's get rid of this device here as well. Okay, let's connect our device back to FA010. Again, notice that it's still shut down. We actually have to power cycle that port. So let's go ahead and do that. Interface FA0/10. A lot of times this is not just protecting our network from the outside world. That's a lot of times what we think of as network security, but also protecting our network from the inside. Let me do this real quick. So shut down. Then no shutdown. And this isn't just because of maybe malicious actors. Okay, this can also be, you bringing in a device that maybe has some malware, or just protecting the network from ourselves, from users just trying to do something that they may not realize they're actually doing something that it may cause an issue with the network, and also protecting the network from ourselves as well, right? Like if I accidentally added a switch down here, that shouldn't be the root bridge. All right. All right, looks like we're back up. Okay, we're back up. Okay, things are looking good again. All right, so that's a little bit on port security. Again, it can also help prevent something called those MAC flood attacks by limiting the number of MAC addresses that can be learned on each specific switch port. And again, that's something that we should be applying to all of our ports. I also want to mention that we can change the violation. What happens when there is a violation. So here it shows that here we go. Violation mode is shut down. That can actually be changed. And in the lab, I talk more about this. But if I do interface FA0/10, I can do switch port. Switch port. I'm all right. Ports, I should just use the tab, shouldn't I? Violation. And these are the different options: protect, restrict, and shut down. Okay, shutdown is the default. Okay, so you can read my lab that talks more about some of these other ones. Okay, let's back up out of here. And let's do a little bit on DHCP snooping. So let me get ready for that. So in this part, we're going to incorporate DHCP snooping to our network. DHCP snooping is a security feature that acts as a firewall between our untrusted and trusted DHCP servers. What does that mean? Basically, what this means is that only on trusted ports will it allow DHCP messages to be received that would normally come from a server, like a DHCP offer or a DHCP acknowledge for IPv4. Those are messages that would only come from a DHCP server. And so we're going to configure, for example, let's do that right now on this switch right here. Okay, 2-4 there. I'm going to, first of all, configure DHCP snooping. So do that. Now, what that does by default is make all the ports on this switch untrusted. So what I'm going to do is make gig 01 a trusted port, because that is where a legitimate DHCP server is. So I'll do interface gigabit 01, excuse me. That's where my DHCP server is. Okay, and I'm going to issue the command IP DHCP, move that out of the way, snooping trust. Okay. Now, all my other ports are untrusted. There are the other ports where I am going to need to configure this on is on my trunk link. Okay, because it's going to be sending it, so it needs to be able to send and receive. For example, this switch here will need to be able to receive messages that come from a trusted DHCP server. So we're going to make this a trusted port here as well. Okay, so actually we're going to make all of our trunk ports trusted. So let me go ahead and do that. First of all, I'm going to do it on this switch here, interface FA01, our trunk link right here. And I'm going to do the same command, IP DHCP snooping trust. All right. I'm going to pause here in a moment. And what I'm going to do while I pause is I'm going to configure these switches here for their trunk links to also be IP DHCP snooping trust. All other ports will be untrusted. Okay, so what I've done, I'm showing you here, access 1-4. I've done this on all the trunk links. IP DHCP snooping, global configuration command, which makes all the ports untrusted. And then this says which ports are trusted. So the trunk ports, FA01, gigabit 102, same. So I've done that on all of the on all of our switches here. Okay. All right, make sure I did the global configuration command here. IP DHCP snooping. All right. Oh, can't spell snooping. All right. Okay, so let's validate that this is indeed working. Make sure we're okay first. So let's go down here, PCG, let's go ahead and just ping the default gateway. First of all, make sure can I release and renew? Release, okay. But can I get a new IP address? No problem. There we go. All right. It's ping 1040.01. That's working. Okay, same thing here, PCH. That up. Just a little room so we can see everything here. Okay. Let's 1040.01. Okay. If I take a look at this switch now and do show IP DHCP snooping. Okay. We can see which ports are trusted and which ports are untrusted. So FA010 is not trusted. Should have shown me this one as well. Wasn't. Sometimes Packet Tracer has a few issues. Let's see if it shows it this time. No, not showing FA020. There's a few things with the ports, with the security stuff on here so That doesn't always work as planned, but it should show you this here is our trusted ports. And this would be our untrusted port. Okay, and there should be two of them there. All right, what happens if we add a rogue DHCP server? Okay, so the first thing that what I'm going to do here is I'm going to configure I've configured a rogue DHCP server. Okay, so service is on. Look, the address is going to give out 192.168.99.9 is the first one, /24. So I've got that all set to go. And this device does have an IP address on the network. Thought it did. There it is, 10.40.0.99. Okay. Okay. Now, what I'm going to do is add it to a port. So let's go ahead here and okay, now this is an untrusted port, FA011, but let's go ahead and make sure that fast Ethernet 011, let's go interface FA011. Make sure that there's nothing that's changed on switch port mode access, default, switch port, on some switches anyway, switch port access, VLAN 40. Okay, so, and we're just going to add it as a server, right? So let's go ahead and do that. Now, before I do that, to show you that it's not getting any address here, what I'm going to do is actually disconnect this link here. Okay. All right, and what we're going to do is let's go ahead and let's actually on this make sure we have port fast on there. Switch port, spanning tree, fast, and spanning tree, BPDU guard. I'm sure all that was already on there. Enable. All right. Okay, I think we're good to go. But that'll bring up this server right away onto the, but it's not doing DHCP, just has a static address, which is fine. FA11. There we go. All right, so let's see what happens when this device here tries to get an IP address. Okay, so I'm going to do IP config release. And then try to do a renew. Now, this is an untrusted port here. Our DHCP server, which was on a trusted port, I've disconnected. Okay. You know, and I could keep on trying this, and it's just not going to get an IP address from this DHCP server. Okay, so anyway, just showing you that it does not get the IP address. Let's do it one more time. Okay, now if I did add this back, let's go ahead. Gigabit 01. I should have done port fast there. So let me pause for a moment so you don't have to wait. Okay, so now we got the green link light there, back to PCA. This might have to take one or two here. Oh, got it right away. All right. So that's DHCP snooping. Now, there are some other things like there's a command called show IP DHCP binding. It does not work properly on Packet Tracer, unfortunately. So let me show you that command, though. Show IP DHCP snooping binding. Okay, doesn't show anything, unfortunately. What this would normally show is any of the MAC addresses that it learns about on the source MAC addresses that it learns about, along with its IP address, because it's what it's doing is snooping the DHCP messages. So the switch actually learns which devices, which ports, on which of its ports, what its source MAC address is and what its source IP address and what its lease time is, and even the VLAN number on that interface. Okay. But unfortunately, it doesn't work in Packet Tracer. I will show you what it would look. Let me show you what it looks like here from my lab document. This is the kind of thing that would show you MAC address, IP address, lease time, how it learned it, VLAN, and the interface. Okay, so the lab document, which is in my GitHub repository now. That's where I put all that stuff. Okay. So one other thing I do want to mention, and then we're just about done here. DHCP snooping is usually used with something called IP source guard. What that does is IP source guard prevents somebody from doing what I just did here, putting on a static, configuring a static IP address. So the command on the interface, if it actually doesn't work on Packet Tracer, but let's say I wanted to prevent somebody from adding a adding a static IP address to a device on that interface. Okay, I'd say, and I would do this on all my interfaces where I have client devices where that I only want them to receive their IP addresses via DHCP. Okay, I have control of that, what IP addresses are going to get. I know who's getting what address. Also, it creates that binding table that's not being shown here. So the user may say, oh, I'll create a static IP address. That way, I can be whoever I want. I can spoof addresses. It's not in the binding table, but let me do it. Interface FA 0/10. I can't do the command. I'll do the command, but it won't work. The command would be IP verify source. Okay. And unfortunately, that is not supported in Packet Tracer. It's all right. Packet Tracer does great things. All right. The last thing I want to mention is a set of commands called dynamic ARP inspection, and then we'll be done. Dynamic ARP inspection, and I talk about this in the lab, but also in my lecture. Okay, what dynamic ARP inspection is all about is using this binding table. So let's go. I'll have to show you this here. Okay, so let me show you the binding table. So using this binding table, okay, which again, these devices can only get their IP addresses from a valid DHCP server, right? Trusted port. We know who has what IP address and what MAC address. Now, if somebody tried to do ARP spoofing, okay, to do a man-in-the-middle attack, and I talk about this in my lecture. But anyway, what they'll try and do is say, change their IP address. Say, oh, maybe this device here will pretend it's 192.168. Oh, sorry, 1040.99.6. This device will try and change its IP address. Well, the switch knows who got what IP address from a legitimate DHCP server, who got what IP address and what their MAC address is. So if you try to be somebody else's IP address, you try to answer an ARP request with an ARP reply with your own MAC address, and instead, if this device here says, yeah, let me tell you, I'm 1040.99.6, and here's my MAC address, the switch will see that and go, no, you're not. You're 99.5. Okay. This is what we call, and it will stop that from happening. This is what we call dynamic ARP inspection. Okay. I will give you the commands here, but unfortunately, once again, Packet Tracer doesn't quite support it as it should. So, but that's okay. All right. So let me do this here. Let's say I was going to do it on a range of ports. Interface range FA 0, 10 to 20. Okay, get that out of the way. Okay, I'd say switch port, access, VLAN 40, which is already configured, right? IP DHCP snooping. Oops, Okay, what I'd say is IP, I forgot one more thing. I'm sorry, let me back up here. All right, be helpful if I was one on the right switch and two reading from my right commands. I knew I was looking at something going, that doesn't look right. It's getting late in this lab. All right, let me go to global configuration mode. All right, so first of all, I better copy and paste because this to add dynamic ARP inspection. Okay, we add this command here to all of our switches. Okay, IP ARP inspection validates source MAC, destination MAC, IP address. Then what we do is on any of our ports where we have servers, switch uplinks, routers, DHCP servers, that sort of thing. For example, let's go ahead and do that. Interface gigabit 01. I'd also do the same thing for FA01. Okay, I would add IP ARP inspection trust, because these are trusted ports. These are the same ports where I'd have IP DHCP snooping trust. So I'd also do the same thing, by the way, and I might as well do it here. Interface FA01 on the trunk link. Yeah. All right. All right. And what this prevents is somebody sending a ARP request for an IP address that they are spoofing. So that would prohibit PCA from sending an ARP I'm sorry, did I say ARP request? Let's do it like this. PCB sends an ARP request for the IP address of the default gateway. Normally, this distribution 2 would send the ARP reply. But what if PCA sent the ARP reply saying, I'm 1040.0.1, and here's my MAC address? So ultimately, what can happen is PCB sends packets for another network to PCA. PCA has actually spoofed them the same thing to distribution 2 that it did to PCA, claiming its MAC address is the MAC address for PCB. So when it forwards those packets to distribution 2 in an Ethernet frames, when those packets come back going to PCB, they'd actually be forwarded to PCA, thinking they're going to PCB. And then PCA would forward those to PCB. So here's our man-in-the-middle attack. That's what this prevents. All right, I know this has been a long lab. I've got more in the lab document. So a lot going on. I hope you found this helpful. Thanks.